We've learned about color theory. Now we're going to learn how light color affects surface color. A very common beginner mistake is to assume that when light hits an object, that the object is simply going to increase in value. And so what I'm going to do here is I'm going to just give you an example of this on the red sphere at the top here. And so the assumption is that, okay, I've done my base color, I've done my local value and my local color, I've added in some shadow, and now I want to light. So I'm going to select the base and I'm going to increase the value of the red, and I'm going to put some red here. And while this is not necessarily untrue under certain lighting conditions, what is more common is that the hue will change based on certain factors. All right, the hue will change. So we won't just increase the value, the brightness of the base red. We're going to change the hue as well. Now, this means we need to go to our color wheel here, our UMB color wheel, and do a nice line split between the warm and the cool colors. All right, so on this side we have the warm colors, and on this side we have the cool. Now, generally speaking, as a general guideline, most of the time we fall under warm lights, whether it's globes in our house, whether it's even fluorescent lights in our house or our offices, or we're outside underneath the sun. Our primary light source usually is warm or fairly warm. When it gets cool, things become a little cold and chilly and feels a bit weird to us. So I think in general, we opt for warmer types of lights or more daylight-like lights because it feels more natural. And when a warm light hits a surface of any particular hue, it tends to cause that surface hue to warm up as well. Okay, so when a warm light hits a particular surface hue, whatever the hue of that surface may be, it tends to cause the surface to warm up as well. Now, there are many lighting circumstances that are possible, but this is a very common one, and in general, this is the most natural looking way to do it. Also, before we go into the examples, is the opposite true? If a cool light hits a surface of a particular view, does that hue cool? And the answer is yes. Of course, it also depends on the coolness of the light and the color of that particular light. But lights are going to fall into a category of warm or cool, and the sun is generally considered warm because it is yellow. So let's move over to our spheres and see what the correct approach would be to lighting them, which doesn't mean just increasing the brightness, but we're also going to warm up the hue as well. So I'm going to switch to the soft brush here, and we're going to start with the red one. Now, if we ask ourselves, what warm area or warm direction will this red move into, this particular red? It's probably going to be toward the orange and the yellow. It's going to warm up towards the orange and the yellow. So we'll pick the base value here, base color, the local color, increase the value because we're lighting this side. So we can increase the value. There's going to be light there. But we also want to move the hue a little bit. And of course, the extent to which you move this is dependent on what you're actually trying to paint. But you want to get the general principle here. And so that would be a good way to light that particular surface. You're changing and shifting the hue of the local color up. You're warming it up as the light hits it. Let's go to the blue. And the blue would warm from the cool here up into a cyan, right? So it's going to warm up into a cyan. So we'll select it, we'll increase the value because we want it to get brighter, and we'll warm it up towards a cyan. And you can see how natural it looks to do a hue shift as well as a value shift. All right. Last but not least, let's do this green sphere. Once again, we'll increase the value, and then we'll hue shift toward a lime green, right? Going into this lime area of the warm colors here. And it provides a fairly convincing, nice warmed hue. It looks naturally lit. Now, a question you might ask is, well, what about the shadow areas? What about the shadow areas on the dark side of these spheres over here? And the key that you want to remember here is that shadows themselves are effectively the absence of light. right? So the absence of light, which means it's the absence of that hue shifting ability of the light. So really, shadows are just a lower value of the local color. Okay, so the shadows really aren't necessarily affected by any hue shifts. You don't want to go and be like, oh, well, I warmed the light, so I'm going to cool the shadows. Though you could do that, and you have creative freedom, generally speaking, shadows are the absence of light. And so you definitely will, if this is your base here, you would just really drop the value for a shadowed area and let the light and the hue shifts in the light do the talking. Okay, so that is in effect how light color affects surface color, or the local color of an object. And when you have warm lights, you want to hue up. That's the end of this lesson. I'll see you in the next lesson.